Testing of enterprise changes are costly and difficult tasks for IT organizations. In this video, we will see how an IT team at a fictional outdoor equipment retailer, the Sample Outdoor Company, can meet these challenges with IBM InfoSphere Optim Query Capture and Replay, also called InfoSphere Capture Replay. When organizations introduce enterprise changes to their database systems, it is hard to know how they will impact business applications. Consequently, before making changes to a production environment, they need to test the changes carefully to ensure that no service disruption or performance degradation is introduced. Issues like these might result in costly rollbacks to restore service. Even worse, it might cause them to miss customer service level agreements, negatively impact customer satisfaction, and lead to loss of business opportunities or revenue. IT teams need to create and run reliable, efficient, and comprehensive test workloads that simulate production. This can be a time-consuming, labor-intense, and costly process. In fact, automated regression tests commonly cover only a small fraction of the production workload, and sometimes they do not include the right mix of application stacks such as web servers and application servers, or the number of users that are normally encountered in production. To help organizations meet these challenges, IBM has developed InfoSphere Optim Query Capture and Replay, a web-based tool that lets you capture production workloads, replay them in test environments, and analyze the impact that enterprise changes might have. Let's see how the IT team at the Sample Outdoor Company uses InfoSphere Capture Replay to efficiently validate planned changes to their database production environment. In this scenario, Shelley, a DBA with the company, proactively looks for opportunities to tune and improve the performance of her company's web applications in production. Before she makes any changes to the production environment, she wants to use InfoSphere Capture Replay to verify in a test environment that the changes will improve performance and that they will not cause any problems. The verification is done in two stages. In the first stage, Shelley creates a baseline workload to validate that the test environment approximates the production environment. She completes the following 4 tasks. First, she captures a production workload during a time of representative database traffic for the applications that she is interested in. Second, she prepares the test environment by restoring a subset of the production database on a test database, and by transforming the raw captured workload to a format that can be replayed on the test database. Third, she replays the captured workload in the test environment. Last, after the workload replay completes, she creates a report to compare and analyze the accuracy of the replayed workload. In the second stage, Shelley tunes her test database environment and then validates that the baseline workload runs successfully with improved performance in the tuned environment. She completes the following tasks. First, she tunes the test environment. Second, she replays the baseline workload in the test environment. Finally, she analyzes the impact of the tuning. Let's see how Shelley can easily use InfoSphere Capture Replay to complete the scenario. First, Shelley logs into InfoSphere Capture Replay and opens the SQL Workloads page to schedule a production workload capture. She clicks Capture and enters a descriptive workload name. She selects the production database from her list of database connections. She schedules the start time and a duration of 60 minutes. She adds a descriptive note to help her identify the workload later. Finally, before she can schedule to capture the workload, she needs to enter user credentials to validate that she is authorized to capture workloads in the selected production database. This workload is now scheduled to be captured. Later, Shelley checks back to see that the workload has been captured, and then prepares the test database for the replay. In general, the test database needs to be reflective of the state that the production database was in before the production workload was captured. This can, for example, be done by restoring a backup image. In this example, Shelley created the relevant database objects and used Optim Test Data Management to create a subset of the production data, which she then restored on the test system. Now Shelley transforms the captured workload to a replay-ready workload. She selects the database connection for the desired subset database. She enters and validates the database user credentials that will be used to run all captured SQL statements on the test database. She proceeds and provides the required user credentials to confirm that she is authorized to transform the workload. She can monitor the transform progress in real time or review the results after the operation has been completed. After the transform has completed, Shelley can replay the workload on the test database. She verifies that the correct replay database is selected. She then replays the workload. While the workload is replaying, in- and outbound database traffic is automatically captured as a new replayed workload. This allows Shelley to later compare the replayed workload with the original captured workload, or with subsequent replayed workloads on the same database. After the workload has replayed, Shelley moves on to the Compare and Analyze task to validate that the replayed workload is a valid baseline. Shelley now creates a report to compare the captured workload and the replayed workload. She verifies that the correct captured and replayed workloads are selected and starts the report generation. The report is used to determine the accuracy of the replayed workload and to identify performance differences. Shelley first validates that the replay was accurate. The top of the grid shows the number of consolidated and unique SQL statements, and the total number of executions during this 1 hour period. Shelley notices that there are some unmatched SQL replays with different number of rows returned. This is as expected because the replay is executed on the subset database with less data. Shelley clicks the link to drill down to view the aggregated information for each unique SQL statement that return different rows. The report consolidates the SQL statements by grouping the matching SQL and replacing literal values with parameter markers. In general, unmatched SQL statements can be removed at the transactional level, and then the workload can be saved as a new replay-ready workload. In this example, since the replay is on a data subset, Shelley keeps these unmatched SQL statements. If it is critical to operate on the same amount of data, she would prepare the test database again by adding more data using Optim Test Data Management and replay the workload. Shelley briefly reviews the transaction-level metrics. The transaction replay comparison grid shows information that is aggregated at the transaction level. As expected, Shelley notices that there are some transactions with different number of rows returned. Next, Shelley wants to make sure that there were no performance anomalies detected. She notices that there is a bit of improvement in the response time, as expected, because the workload replayed on a subset of data. The number of executions chart shows that the captured and replayed workloads match, but, as expected, the rows returned chart shows that fewer rows were returned when the workload was replayed. With this report showing the accuracy of the replayed workload, Shelley confirms that she has a good baseline for the test environment, and she moves on to stage 2, where she will assess the impact that the tuning will have. As part of the prepare step, Shelley reset the test database to the state it was in before the first replay. She also applied the tuning recommendations that InfoSphere Optim Query Workload Tuner identified, by creating the 2 indexes as recommended by the Workload Index Advisor. Now, Shelley replays the workload again on the tuned test database. Next, Shelley creates a report to analyze the impact that the new indexes have made on the workload. She selects the previously replayed baseline workload and the newly created replayed workload to compare. This time, as expected, the replay result accuracy report shows a 100% match for both SQL statements and transactions. Shelley reviews the response time report, which shows that the cumulative response time improved more than 50%. The SQL execution chart shows similar number of executions, and the rows return chart shows exact matching as expected. To identify the SQL statements that have benefited from the indexes, Shelley now drills down into the list of improved SQL statements. At the top of the list are the SQL statements with response times that have improved the most. Shelley drills down further on the first entry to see the aggregated SQL statements and its execution details, including the top improved and regressed replay response time, if any. Drilling down to the list of regressed SQL statements, Shelley sees that there are insert statements at the top of the list. This is expected because of the new indexes. After further analysis of the report, Shelley confirms that the positive performance gain results from the new indexes. She plans to implement these changes on the production with great confidence. Shelley is happy that she can easily and quickly validate the impact of the tuning activities on the actual production workload. We have seen how Shelley can use IBM InfoSphere Optim query capture and replay to save IT time and resources when validating the impact of planned enterprise changes. InfoSphere Capture Replay lets organizations fully assess the outcome of enterprise lifecycle changes such as hardware or software upgrades, migration, consolidation, retirement, performance tuning, or addition of new applications, before deploying these changes to production. The result is a significantly less costly and consistent process for testing. Changes to critical systems can be tested rigorously. Replays can be tailored to meet a variety of test objectives such as performance stress test, capacity planning, and growth. With InfoSphere Capture Replay, organizations can reduce the cost and the risks of lifecycle changes, avoid potential service disruption and expensive rollbacks, and meet SLAs for availability and reliability with minimal performance overhead, with support across heterogeneous enterprises that include all major database servers. For more information about InfoSphere Optim Query Capture and Replay and the related InfoSphere Optim offerings, visit us on the web at the links shown here.